You're listening to the N2K Space Network.
Imagine a world where you're always one step ahead of cyber threats, where your defenses are impenetrable because you see what others don't. Welcome to Team Cymru's Threat Intelligence Solutions. With real-time access to the world's largest threat intelligence data ocean, they enable you to turn the tables on attackers. Transform your security from reactive to proactive through accelerated threat hunting and incident response, made possible through automation. Empower your team with visibility and insights to start defending your organization like never before. Team Cymru. Be the hunter, not the hunted. Learn more at team-cymru.com/cyberwire. That's team-cymru.com/cyberwire.
It's been really interesting to watch the UK invest in amping up its domestic space capabilities. The nation has a long space heritage, and especially has a proud tradition in satellite manufacturing. And in recent years, the UK has put in a concerted effort to branch out its space capabilities and renown. Exhibit A, Saxavord Spaceport. Exhibit B, the Astra Carta. But there's also absolutely nothing wrong with leaning into what you're known for. And when it comes to making good satellites, the UK government is saying, yeah, we're all in.
T-minus 20 seconds to LOS T-dress. Go for deploy. Roger roll.
Today is March 27th, 2024. I'm Maria Varmazes, and this is T-minus. UKSA calls for communication constellation proposals. NASA announces its science instruments for Artemis III. China launches a new climate satellite. And our guest today is Brad Appel, Chief Technology Officer at Ursa Major. We're going to be discussing engine manufacturing, and Brad will be telling us about Ursa Major's new Draper engine. So stay with us for that chat. Happy Wednesday, everybody. Let's dive into our intel briefing for today. The UK Space Agency's Connectivity in Low Earth Orbit program got a boost in the UK's spring budget, with an allocation of £60 million from the UK government to boost UK-based SATCOM's innovators. The £60 million in funding is available starting today, with awards of up to £20 million per project. As the Connectivity in Low Earth Orbit program name perhaps suggests, this funding is meant to help accelerate UK-based satellite research and development, specifically for beefing up satellite constellation capabilities. The £60 million available starting today is part of a total £160 million that the UK government will be investing in this program over the next 4 years. Germany-based Polaris Spaceplanes has signed an investment and cooperation memorandum of understanding with the Swiss-based Aero Challenge Group, also known as ACG. The agreement will cover an initial multi-million euro investment of ACG in Polaris, planned to be followed by a long-term strategic and funding partnership in order to make European space planes become reality. ACG belongs to the Swiss-based family office AFK Enterprise, which already executed investments in German and other European aerospace companies. The governments of the US and France held their second meeting of the Comprehensive Dialogue on Space in Washington, D.C. earlier this week. The initiative, which was announced in November 2021, aims to ensure a whole-of-government approach to bilateral space cooperation. According to the White House statement on this event, the dialogue underscores the importance of the US-France alliance's more than 60-year relationship in space and recognizes the growing nexus of civil, commercial, and national security space activities and the increasingly interconnected nature of all three sectors. During the meeting, US and French officials exchanged information on respective national space policies, including the US framework for novel space activities and France's forthcoming update of its national space law. Both sides reiterated their strong determination to expand already robust bilateral cooperation in a variety of areas, including addressing the climate crisis, advancing national security space cooperation and information sharing, and strengthening bilateral commercial space cooperation. NASA says it has chosen the first science instruments designed for astronauts to deploy on the surface of the moon during Artemis III. Once installed near the lunar South Pole, 3 instruments will collect valuable scientific data about the lunar environment, the lunar interior, and how to sustain a long-duration human presence on the moon, which will help prepare NASA to send astronauts to Mars. The payloads include the Lunar Environment Monitoring Station, also known as LEMS, which is a compact autonomous seismometer suite designed to carry out continuous, long-term monitoring of the seismic environment, namely ground motion from moonquakes in the lunar South Pole region. The LEAF, or Lunar Effects on Agricultural Flora, will investigate the lunar surface environment's effects on space crops. And the Lunar Dielectric Analyzer, or LDA, will measure the regolith's ability to propagate an electric field, which is a key parameter in the search for lunar volatiles, especially ice. All 3 payloads were selected for further development to fly on Artemis III, which is targeted to launch, fingers crossed, in 2026. The Space Development Agency is looking for commercial space companies to move inactive satellites out of low Earth orbit at the end of their service life. The SDA updated its call for executive summaries, proposal abstracts, and proposals for novel architecture concepts, systems, technologies, and capabilities. The goal here is to enable leap-ahead improvements for future proliferated warfighter space architecture tranches, capability layers, or to enable new capability layers to address other emerging or evolving warfighter needs. Interested companies are encouraged to submit proposals by May 30th, 2024. Sidus Space has announced its year-end financial results following the first launch of their LizzieSat program. Carol Craig, founder and CEO of Sidus, told investors on the call that 2023 was a pivotal year for Sidus, culminating with the successful launch of our first LizzieSat on the SpaceX Transporter-10 rideshare mission earlier this month. LizzieSat 1 is the first of several satellites planned for launch to low Earth orbit. And the company also says that they are quickly building a constellation of 3D-printed, AI-enhanced satellites, with 2 more LizzieSats manifested for launch before the end of the year. The cost of revenue decreased 26% for the 12 months ending December 31st, 2023 for Sidus Space, but the company remains optimistic that 2024 will be their year. Earlier today, China launched a Long March 6 rocket carrying an environmental monitoring satellite called Yunhai 302. Chinese media say that the spacecraft has entered the preset orbit. The satellite is tasked with atmospheric and marine environment detection, space environment monitoring, disaster prevention and reduction, and scientific experiments. Speaking of launch, all eyes are on the skies above Florida ahead of the final launch of ULA's Delta IV, which is still planned for tomorrow. With intermittent clouds, rain, and wind in the forecast, there's a good chance that the final flight of the Delta IV could be moved a few times ahead of launching the National Reconnaissance Office's NROL-70 mission. We will obviously update you in tomorrow's show. And to close out our briefing today, here's something perhaps to debate amongst friends and coworkers. Martin Rees, the Astronomer Royal of, wanna guess, the UK, has reiterated his long-held opinion that human spaceflight has questionable value, and we should, instead, only use robots to explore space. This is not a new opinion for Rees, saying recently that now that robots can do the things that humans were needed for 50 years ago, the case for sending people is getting weaker all the time, and that any person who wants to go to space should pay their own way, not the taxpayer. And certainly many space programs do use humanoid robots as a step before human spaceflight, like ISRO and NASA for one, and the Astronomer Royal is not the only prominent member of the scientific space community who has expressed misgivings about the long-term viability of human spaceflight. What do you think of this all-or-nothing view? To me, I get the idea of letting robots handle the risk, but it seems a bit of a shame to let them have all the fun, too. Our inbox is open, y'all. space@n2k.com. We'd really love to hear your take on this. And that's it for our briefing for today. Check out the show notes to find links to further reading on all the stories that we've mentioned in our show. We've included a better explanation of yesterday's announcement of the Texas Space Commission, as well as a story from Wired on the next generation of cancer drugs that plan to be made in space. Hey T-Minus crew, if you find this podcast useful, please do us a favor and share a 5-star rating and short review in your favorite podcast app. That will help other space professionals like you to find the show and join the T-Minus crew. Thank you so much for all your support, everybody. We really appreciate it.
And now, a word from our sponsor, Zscaler, the leader in cloud security. Cyber attackers are using AI in creative ways to compromise users and breach organizations. In a security landscape where you must fight AI with AI, the best AI protection comes from having the best data. Zscaler has extended its zero-trust architecture with powerful AI engines that are trained and tuned by 500 trillion daily signals. Learn more about Zscaler Zero Trust Plus AI to prevent ransomware and AI attacks. Experience your world secured. Visit zscaler.com/zerotrustai.
Our guest today is Brad Appel, Chief Technology Officer at Ursa Major. I started off by asking Brad about the first flight of their Hadley engine design on the recent Straddle launch demonstration flight.
We've been preparing for this for years, really. Hadley is the sort of the bedrock product out of Ursa Major that the company was started around many years ago. We've gone through a number of block upgrades and product variants for different applications, everything from launch to hypersonics. Straddle launch was our first flight with a particular variant of Hadley, and we're so thrilled that Straddle launch team just executed flawlessly. They've been such a good customer and partner with us, and it was really a beautiful mission.
Were you at Mojave by any chance? Like, were you around? Did you see any of how the mission went down? I'm just so curious how it went.
I was lucky enough to be there, and the whole Straddle launch team was very operationally focused, of course, and dialed in. And because this is a first test flight, everybody's anxious around what the results are going to be. Historically speaking, first rocket test flights aren't typically all that successful, actually. And this is a particularly challenging mission set from a technology standpoint, the air launch and all that. The result was very successful, first try. And so I think it's just a testament to extreme focus on mission assurance, years of engineering going into it, and a really rigorous sort of set of checkouts and preparation for flight.
Yeah, congratulations to you and everybody who worked on the Hadley. And I know work continues, but still, this is a fantastic milestone. I imagine that everyone was feeling pretty good after that test flight. I'm sure the work continues. What's next for the Hadley?
Well, we certainly are looking forward to a number of future missions with Straddle launch, right? So that's just the beginning. And as that hypersonic testbed flies more and more, that'll be unlocking a sort of an industry of its own there. So we're excited about all the missions with Straddle launch for that Hadley variant. And then the Hadley engine itself has a set of customers in the small launch industry. And we're looking forward to, in the upcoming years, seeing missions there. It's interesting, the Hadley program as a whole actually just hit another milestone last week where we crossed 100,000 seconds of runtime for the whole family. So obviously, vast majority of that being ground testing. And so that's just an enormous milestone that talks to the reliability and the performance upgrades we've been able to develop into that engine line. So Hadley, has that hypersonics testbed platform. It's got a couple of small launch customers. And then one of the spinoffs of Hadley that we've been working on a lot lately is a different engine program, but similar thrust class, and that's called Draper, where we
Yes.
we've we've taken Hadley's a liquid oxygen kerosene rocket engine, and the liquid oxygen, of course, is cryogenic. And we've taken it upon ourselves to develop a sort of a derivative, a distant cousin, I'd say, of Hadley that uses a storable oxidizer. So it can be used for missions where you can't always spend a few hours loading propellants ahead of time and you want to be ready to go on demand.
Yeah, I was going to say, I noticed that Draper was announced last year, and I was curious, a year is not that long a time, I suppose. I mean, things take time. I was going to ask just sort of how are things going in Draper development?
They're going very well. So, we signed a contract with Air Force approximately a year ago to kick off a full engine program, which followed on the heels of some component technology development. In about that 12-month span, we've gone all the way from kicking off an engine design, thermodynamic state point, very early parts of an engine program, to actually fully hot firing the real thing just in this last week, actually. So we've been able to consistently take, we used to say 1 to 2 years, a little bit closer to 2 years for a clean sheet design to first engine hot fire here. But for this Draper storable engine, we've been able to hit right around the 12-month mark, and it works great. And it's a bit of a novel engine cycle, and the team's pretty excited. So now we're off to the races on maturing that engine.
Yeah, I was going to ask about the engine cycle because I'm not super up on my rocket technology, but I do understand that it is unique, and I would love if you could help me understand a bit what is so unique about it and why is it so special?
Well, when you switch to a storable propellant set from liquid oxygen, generally there can be some performance compromises on specific impulse. But what we've done is made sure that it's also a closed cycle, the way it operates. And so all of our other engine programs, Hadley, Ripley's another one, they're all Ox-rich staged combustion, and we have some other types of staged combustion engines in development. And the idea there is you channel all the chemical energy into one combustion chamber and not one nozzle, as opposed to diverting some of it to power turbine and then dumping that at lower energy, lower velocity. So net result is much higher specific impulse when you can do a closed cycle like that. With the storable propellant that we're using on Draper, can't necessarily reuse the same engine cycles that liquid oxygen tends to work well with. And so we've had to come up with a novel cycle that can still achieve that closed loop where all of the propellant goes out of one nozzle. But it's been fun to sort of come up with our own thermodynamics design a little bit and then see it actually work.
I was going to say, you've mentioned a bunch of things that are on their own extremely challenging, and you're combining them. I'm like, that's got to be a really fun, yeah. Of
course, in addition, like Hadley and our other engines, Draper's predominantly additively manufactured for those core components.
The engineer part of me is like, those have got to be really fun problems to solve. Extremely challenging, but super fun. I'm wondering what sort of Draper and its development means. I'm thinking really macro right now, but like, what does it mean for hypersonics development in America in general? If any philosophical thoughts on that?
Well, we think that liquid rocket engines, liquid propulsion, fill a niche that's important for the hypersonic landscape. So currently, when you look at hypersonic development, there's a role for solid rocket motors, typically to boost up certain vehicles and payloads. There's a role for air-breathing propulsion, ramjets and scramjets to sustain relatively long ranges. But liquid propulsion can do some unique things that either of those solid and air-breathing elements don't do by themselves. And so one of the key aspects there is energy management and just the ability to almost real-time change the mission. And so the liquid rocket engine Draper can stop and restart effectively an infinite number of times. It can throttle down very low, can provide thrust vector control. In contrast to air breathing, it can operate at very high altitude. So if there's any exoatmospheric or space maneuvers, it runs fine there. We are also looking at an in-space application for it. And so one of the exciting things about going to the storable propellant set is truly across three sort of domains, hypersonics, launch, and then especially in space, there's a lot of demand to have that ability to just decide your mission later, have an asset just standing by. And then, if you need a high thrust profile, low thrust profile at any altitude, it can go execute on that. So providing that flexible propulsion, we find a lot of use across the applications. So hypersonics and in space are both looking interesting.
I'm thinking back on the TA-1 mission, the one that just happened with Hadley. With Stratolaunch and Ursa Major both being privately funded, your thoughts on sort of this latest success and maybe what it means for commercial spaceflight.
It's important to consider a little bit of the model there, where Ursa Major was able to provide a high-performance rocket engine to Stratolaunch. It enabled both firms and especially Stratolaunch, to execute a very difficult and high-performance mission with private backing in a way that many other firms all over the world would love to be able to do that kind of mission. So when we think about Hadley and our broader line of rocket engines and other propulsion types, that's sort of the basis of the model, is that as opposed to a firm trying to vertically integrate everything under one roof, which has its advantages on perhaps cost structures in some cases, but that comes with compromises where you can't really focus and drill deep into performance and into specific elements like engines and propulsion. In contrast, when you have a company like Ursa Major, who's focused on propulsion, and so we can go after the highest performance version of that, and we're approaching the market spreading cost and risk across multiple firms and government, really can result in a win-win where a customer can go get a head start, both from a cost standpoint and from a technology standpoint, and with a respectively smaller team, go pull off a pretty exciting mission.
I want to just ask one last question, if I may. Just sort of what's coming up next that you might want to highlight from Ursa Major. I mean, I know you all are working on a lot of stuff, but I figured I would just be like, what should we expect?
Well, we're excited. I mean, we have a lot of propulsion verticals going. So, we're obviously excited for additional Hadley flights coming up. We're excited for the Draper engine to get fielded as well and finish its development. We've also put a considerable effort into our solid rocket motor division, and that's going to be seeing some big milestones here as well soon. In addition to that, we've been advancing development of some cryogenic, full cryogenic fuel, liquid methane rocket engine development. So we'll be hearing about some updates there soon too. But basically across the domains of launch, in-space, hypersonics, and solid rocket motors, we see ourselves as uniquely able to fill these propulsion niches, go advance high technology and supply chain robustness, and then let other customers and vehicle providers and integrators go take advantage of it.
We'll be right back.
This podcast is sponsored by SRM, your first call for cybersecurity and investigations. SRM is a global leader in cybersecurity, trusted by the world's most successful businesses to provide unrivaled cyber incident response, proactive services, and digital forensics. SRM invests in creating a team culture that allows the sharpest thinkers to thrive and deliver award-winning results for their clients. Their solutions and advice are specific for each client, actionable, and delivered in language that they can easily understand and act on. What executive team doesn't need that kind of service in the face of today's cyber threats? To learn more about why SRM should be your first call, no matter what your cyber challenges are, search Your First Call.
Welcome back. I love this story that NASA just published about an event last month at their Langley Research Center in Virginia. Maybe don't listen to this part of the show if you're feeling a bit peckish, or do, whatever. Late February, Langley's halls were turned into a pop-up kitchen for a competition featuring teams of local high schoolers who are studying culinary science. This was an official NASA event called the NASA Hunch Culinary, and Hunch stands for High School Students United with NASA to Create Hardware. That is quite an acronym, NASA, just saying. Anyway, Hunch is a project-based learning program for high schoolers to participate in the design and fabrication of real-world products for NASA. These culinary students were creating not just nutritious, but actually delicious recipes for astronauts that also had to follow a specific food processing procedure. So, these students in this challenge had to make a savory breakfast dish that includes a vegetable. No slice of toast and run out the door for our astronauts. No, sir. This savory, veg-included breakfast also has to be between 150 and 350 calories, contain less than 12 grams of fat, and less than 250 milligrams of sodium, and have at least 1 gram of fiber, and I quote NASA on this one, must process well for spaceflight and for use in microgravity. And for those of you like my grandmother who are more of a measure salt with your heart kind of person, just to be clear, 250 milligrams of table salt is a little under a gram, or about 1/6 of a teaspoon. So making something savory with just a hint of salt was something many of the students found particularly challenging. But they also found some interesting solutions with that challenge, like adding in some heat with some poblano peppers, a very smart move. Some of the recipes in the competition that were featured were vegetable scrambled eggs, and also a sweet potato hash with ground turkey. Yeah, now I'm really hungry. Okay, so the highest scorers from this competition will go on to a final round at Johnson Space Center in Houston, where their creations will be taste tested by proper astronauts. And the winning culinary creation will go up to the International Space Station for the crew there to enjoy. What an incredible opportunity for these students. We have come such a long way from freeze-dried ice cream. That is it for T-Minus for March 27th, 2024. For additional resources from today's report, check out our show notes at space.n2k.com. We'd love to know what you think of this podcast. You can email us at space@n2k.com or submit the survey in the show notes. Your feedback ensures that we deliver the information that keeps you a step ahead in the rapidly changing space industry. N2K Strategic Workforce Intelligence optimizes the value of your biggest investment, your people. We make you smarter about your team while making your team smarter. This episode was produced by Alice Caruth, mixing by Elliot Peltzman and Trey Hester, with original music and sound design by Elliot Peltzman. Our associate producer is Liz Stokes. Our executive producer is Jen Iben. Our VP is Brandon Karp. And I'm Maria Varmazis. Thanks for listening. We'll see you next time.
You don't need luck when you have the right tools to help you prepare for your next IT or cyber credential. At N2K, we've helped over 500,000 practitioners level up their careers with Cert Prep training. And now you can score 25% off our best-selling practice tests, such as Security Plus, CSSP, CCNA, PMP, and more. Visit n2k.com/certify and use promo code NETWORK, that's NETWORK, at checkout to save 25% on your purchase. Offer ends March 27th. Happy learning.